You know that feeling. You're staring at just like tons of information, articles, notes, whatever, trying to figure out what actually matters.
Oh, yeah. Try and get the key insights fast.
Exactly. And, well, in the business world, with data, it's that feeling times 1,000, isn't it? Companies have data just everywhere. Databases, logs, apps, the cloud.
All over the place. And they need to somehow pull it all together, clean it up, get it into shape.
Right, transform it, and then load it somewhere. They can actually use it for analysis. Find those nuggets.
And that whole process, extract, transform, load, that's ETL, it's fundamental. It's how you turn raw stuff into something smart.
Totally. And today we're doing a deep dive into how AWS tackles ETL, specifically looking really closely at one of their main tools, AWS Glue.
Right. We've got a mix of sources here, articles, blogs, even a video comparing things. They cover what Glue is, how it stacks up against other AWS options like EMR or data pipeline.
Yeah, and DMS too, right? And how it compares to the big traditional ETL software people might know. Plus the costs, that's always a big one in, real-world examples.
Mm-hmm. So our mission really is to unpack all this, pull out the important bits from these sources, understand the practical differences between these tools, especially Glue.
And help you figure out, when you'd pick one over the other, keeping an eye on those costs and best practices everyone talks about.
Exactly.
Okay, so let's get grounded. What exactly is ETL, again, briefly, and where does AWS Glue fit in, based on what we've read?
So ETL, like we said, extract data from point A, transform it, clean it, reshape it, whatever, and load it into point B, usually for analysis. Simple idea, often complex reality.
And AWS Glue. The sources call it a fully managed ETL service from AWS. What does fully managed actually mean here?
It basically means AWS handles the servers, the infrastructure for you. You don't provision servers. You don't manage clusters for your ETL jobs. You don't worry about scaling up or down. You just define your job, point Glue at your data, and it handles the compute needed to run it.
Okay, so that's the serverless angle. Sounds like a big deal for cutting down on, operational headaches.
It really is.
What else makes Glue stand out in these sources?
Well, a huge thing they highlight are the Glue crawlers. Think of them as automated bots.
Bots.
Yeah, you point them at your data sources. Could be files in S3, tables in RDS, whatever. They go out, find the data, figure out the format, even tricky stuff like JSON or Parquet, guess the schema.
Schema meaning the structure, the columns, and data types.
Exactly. And they store all that information, that metadata, in a central place called the AWS Glue data catalog.
Okay, so instead of me manually digging around to figure out what data I have and what it looks like, the crawler does that detective work.
That's the idea. It maps out your data landscape. And then based on that map in the data catalog and how you want to transform things, Glue can actually auto-generate ETL scripts for you.
Seriously, it writes the code.
Well, it gives you starter code, usually Python or Scala, running Apache Spark underneath. You can then take that script and tweak it either using a visual editor or just editing the code directly.
Huh. The AWS source had a good example, like an app developer analyzing ad clicks, which are JSON files in S3.
Right.
And also user profiles from a regular database like RDS. And they want to get it all into Redshift, their data warehouse.
Yeah, classic scenario. Without Glue, you'd be writing code to parse that JSON, code to connect to the database, code for the transformations, managing how to load into Redshift. That's a lot.
Infrastructure, code, the whole deal.
Right. But with Glue,
You just point the crawler.
you point a crawler at S3, another at RDS. They find the data, figure out the schemas, populate the data catalog. Then you set up a Glue job.
And tell it what to do. Like flatten the JSON, pick certain columns.
Exactly. Join the data, change types, whatever. Glue generates that starting Python or Scala Spark script. You review it, maybe adjust it.
And then you hit run, and Glue handles spinning up the computers, doing the work, loading Redshift.
That's the promise. The source mentioned this could take what used to be months of dev time and really streamline it, get you going faster.
Okay, that makes sense.
But it's important context. As one source pointed out, Glue isn't the only way. You still have those big traditional enterprise ETL tools, Informatica, Talend, often used in places with lots of older systems.
Right, the established players.
And you also have things like Apache Airflow, which are more about orchestrating complex workflows that might include ETL but also do other things. Glue fits into that bigger picture.
Okay, so Glue is AWS's serverless cloud-native ETL approach. But like you said, AWS has other tools that move or process data. It gets confusing. Glue, data pipeline, EMR, DMS. How do they differ?
Yeah, it definitely can be confusing. They overlap a bit, but they have different sweet spots. The sources help break it down.
Let's start with AWS Data Pipeline. What's its deal?
Data pipeline comes across more as an orchestration service in the sources. It's got a web UI, and it's designed for scheduling and managing complex workflows. Workflows that might hit multiple AWS services, maybe even on-prem stuff.
Okay, so connecting steps together.
Exactly. It can move data, handle batch or real time, but the sources stress its strength is in the workflow management, the dependencies, not so much in deep built-in data transformation power like Glue or EMR have.
Got it. So more the conductor than the instrument player itself.
Good analogy. Then there's AWS Batch.
Batch feels different again. Isn't that just for running, like any containerized compute job?
Mostly, yeah. You could write your own ETL script, package it in a container, and run it on batch. It's scalable, flexible if you want fine-grained performance tuning,
Right.
but it's not purpose-built for data integration like Glue is. Glue has Spark built-in specific ETL libraries. With batch, you're building the ETL logic pretty much from scratch and managing the environment definition more, even if batch handles the servers.
Okay, custom code on scalable compute, but less ETL-specific help. How about AWS Database Migration Service, DMS? The name sounds relevant.
It does, but it's very specific. DMS is all about database migration, moving databases from, say, your data center or another cloud into AWS.
Ah, okay. Like a moving truck for databases.
Pretty much. It handles converting schemas between database types, replicating data with minimal downtime. Its job is the migration, not the ongoing day-to-day ETL for analytics.
So you might use DMS to get your history into AWS and then use Glue for the continuous updates.
That's a really common pattern, yeah. DMS for the initial move, then Glue or something else for the ongoing pipeline.
Okay, and the last big one to compare with Glue for ETL, AWS EMR, Elastic MapReduce.
Right. EMR is AWS's big data platform. Uses things like Spark, Hive, Presto.
So it can definitely do ETL.
Oh, absolutely. Very powerful ETL using Spark. But the key difference the sources hammer home compared to Glue is, with EMR, you manage the underlying clusters.
Meaning I have to set them up, configure them, decide how many servers, scale them, patch them.
Yep. AWS manages the base EMR service, but the cluster configuration, lifecycle, operations, that's more on you. And that, as one source notes, often means higher people cost. You might need dedicated engineers who know Hadoop or Spark cluster management.
Ah, whereas Glue hides all that complexity.
Exactly. Glue abstracts the infrastructure away. You focus on the ETL logic, not managing servers.
Okay, this paints a much clearer picture of the landscape. So now the million-dollar question the sources tackle,
Yeah.
how do you choose? Especially Glue versus EMR for ETL work, and Glue versus those traditional tools.
Yeah, this is where the practical stuff comes in. Glue versus EMR for ETL. It's not just about features, it's about how you want to operate, your costs, and what your jobs look like.
Glue is serverless, less operational work. We got that.
Right. And that pay-per-second pricing for Glue jobs, that's huge. You only pay when it's actually computing.
Unlike EMR clusters.
Well, one source pointed out that in reality, lots of EMR clusters just get left running 24/7 because it's easier, or jobs run unpredictably, so you pay for all that idle time.
Ouch. That idle cost adds up fast.
It can be a massive difference in the total bill. Now, sources do say Glue might look, say, 20–40% more expensive per hour than a similar size EMR cluster if that EMR cluster was running flat out all the time.
What?
But for typical ETL jobs running maybe daily or hourly, for minutes or a few hours, the total cost with Glue is often way lower because you're not paying for idle time, and you have lower admin costs. No cluster admin needed.
So the per minute rate might be higher, but you pay for far fewer minutes overall, plus save on people time.
Exactly. Glue often wins on cost for those common intermittent ETL workloads where managing an EMR cluster is overkill.
So when does EMR make sense for ETL? When is it the better choice?
EMR becomes necessary, according to the sources, when your ETL needs are just massive. If you need more compute power, then Glue offers one source ballparked Glue's max at around 100 DPUs, which is like 1,600 gigs of RAM, 400 CPUs.
Okay, serious scale.
Yeah. At that point, you probably have a dedicated data engineering team anyway, and the control EMR gives you might be worth it. Also, EMR is the platform for broader big data tasks beyond just ETL. Like what?
Like complex machine learning using EMR Studio, or if you need interactive query tools like Hue, Presto, Hive directly on the cluster.
Yeah.
Those only run on EMR. If you need that ecosystem, you'll probably do your ETL on EMR too.
Got it. That clarifies Glue versus EMR. Now, Glue versus the traditional ETL giants, Informatica, Talend, etc. One source really dug into this.
Yeah, That comparison was interesting because it focused on factors beyond the tech specs,
Mm.
like cost structure. Traditional tools often have hefty enterprise license fees, sometimes not very transparent.
Right, the big upfront or annual license cost.
Exactly. That source specifically said Informatica's cost was mostly licensing, even if the server costs were similar to what Glue might use.
And getting started faster with Glue.
That source measured it. 8 weeks to get the first pipeline into production with Informatica versus just 2 weeks with Glue in their test. But on the flip side, traditional tools sometimes have more built-in connectors, especially for older on-prem systems.
Ah, so connecting Glue to, say, an old on-prem Oracle database might take more custom coding. Potentially, yeah. The example mentioned needing extra time for that compared to a tool with a native Oracle connector.
So where does Glue win then in that head-to-head?
Generally, faster time to value, getting that first pipeline running. While the AWS bill for Glue might look higher than just the server cost for a traditional tool when you add in the license cost and the engineering time.
Total cost of ownership.
Right. TCO can be lower or competitive with Glue. And here's a key hidden factor that source raised: developer experience.
How so?
If your team already knows Python and Spark really well, developing in Glue feels natural, probably faster than learning a proprietary UI of a traditional tool, even if that tool has more buttons.
Ah,
The source had an example where a team took 3 times longer with Informatica, even though it was feature-rich, just because their team lived and breathed Python Spark, not that specific tool's interface. Developer speed is a huge, often underestimated cost factor.
wow, that's huge. It's not just the tool, it's the team. What about vendor lock-in? Always worry.
Absolutely. The source argued that, yeah, you're locked into AWS with Glue, but because the actual transformation logic is standard Apache Spark code Python or Scala, it's potentially more portable than logic built in a proprietary drag-and-drop tool or its unique scripting language.
Interesting.
They mentioned having to completely rewrite Informatica logic to move to Glue. So the lock-in is different. Glue Spark code could theoretically run elsewhere, maybe on Databricks or your own Spark cluster. Proprietary logic is often stuck.
Okay, so Glue gives you standard code, maybe more portable transformations, while traditional tools might have logic that's harder to move, but maybe broader out-of-the-box connectivity.
That's a good summary of the trade-offs. It depends on your integration needs, budget, speed requirements, and critically your team's skills.
And if you do choose Glue, understanding its costs is vital, since it's pay-as-you-go.
Totally. Like we said, it's mostly about DPUs, data processing units used per hour for jobs and crawlers, plus some cost for the data catalog, storage, and requests. Costs scale directly with how much work you do and for how long.
So you want efficient jobs using just enough power. What are the common ways people waste money with Glue, according to the sources?
Over-provisioning DPUs is number one, giving a job way more power than it needs, using the data catalog too much, maybe crawling too often, or storing tons of old metadata, and just plain inefficient ETL scripts that run longer than they should. Longer runtime equals more DPU hours equals higher cost.
Simple math. The sources had some really practical cost-saving tips, though, almost like a checklist.
Yeah, they laid out a good path. First, right-size your DPUs. Don't just guess high, analyze the job. Use Glue job bookmarks. This is huge. It stopped you from reprocessing the same data over and over.
Makes sense.
Optimize your actual ETL code to run faster. Monitor your crawlers. Do they really need to run every hour if the data only changes daily? Clean up old metadata from the catalog.
What else is on that list?
Consolidate tiny jobs, if possible, to reduce startup overhead. Be smart about retry logic so failures don't cause costs to spiral. Use S3 for intermediate data staging. It's cheap. Use partitioning in your data lake so jobs only scan the data they actually need.
Partitioning is key for data lakes, yeah.
Definitely. Also, actively stop jobs that are running way too long. They might be stuck. And finally, just regularly look at your Glue usage and costs using AWS tools. Find the next optimization target.
And AWS gives you tools for that, like Cost Explorer, budgets, CloudWatch.
Exactly. Cost Explorer shows you where the money is going. Budgets can alert you if costs spike. And CloudWatch gives you the metrics and logs from your jobs and crawlers. You need that visibility to apply the tips.
Right. Can't optimize what you can't see. It's good to see these aren't just abstract tools either. The case studies show companies solving real problems.
They really do, like Company X using Glue to pull together messy retail data from different places. They said Glue's automation, the crawlers finding the schemas, the serverless aspect, it all helped them get cleaner data faster and scale it up.
Nice. Getting that single view of the customer or product. What about data pipeline? There was a case study there too.
Yeah, Company Y used data pipelines specifically to break down data silos. Their customer info was scattered everywhere. Data pipeline orchestrated moving it all into one central place, better access, less duplication, better integration.
So data pipeline playing that conductor role we talked about, and DMS for migrations.
Right. An unnamed organization used DMS to move huge amounts of old database data from their own servers into AWS. Big benefit was minimal downtime during the move, and it slotted right into their AWS setup with S3 and Redshift.
These real examples really drive home those hidden practicalities you mentioned, the stuff that doesn't show up on a feature list but matters day to day.
Totally. Development experience is probably number one. Does the tool fit how your team already works? We saw how Python Spark skills made Glue way faster for one team than a feature-rich tool they didn't know.
It's not just what the tool can do, but what your team can realistically achieve with it quickly.
Exactly. Operational monitoring is another. Glue gives you CloudWatch basics, but the sources hinted that getting really deep end-to-end visibility often takes extra custom engineering work on top of Glue.
So building your own dashboards and alerting logic, potentially, adds back some effort.
It's a nuance, yeah. Vendor lock-in, it's real, but maybe different kinds of lock-in, like we discussed with Spark code versus proprietary logic.
Yeah.
In that integration depth, Glue is fantastic inside AWS. Connecting outside to legacy stuff might need more custom work than a traditional tool with decades of connectors built up.
So know your ecosystem inside and outside AWS.
Definitely. Know where your data is coming from and going to.
Okay, pulling this all together. What are the key best practices that emerge from these sources for using AWS ETL tools well? And where is this whole space going?
Well, across the sources, some themes repeat. First, solid data governance and quality. You need policies, ways to check accuracy, manage your metadata well in the data catalog, track lineage, handle security through IAM and encryption, and have backups.
Yeah, garbage in, garbage out still applies, even with fancy tools.
Absolutely. Second, smart scalability. Use the serverless parts where it makes sense, optimize how data moves between services, build fault tolerance into your pipelines, and keep an eye on performance.
And third, cost optimization, obviously. All those tips we discussed, right-sizing, bookmarks, compression, lifecycle policies.
All right, applying those consistently. These practices make your pipelines not just work, but work reliably, scalably, and affordably. And the sources also nod to the future.
Like ETL needing to feed machine learning models.
Exactly. Tight integration with ML services like SageMaker is becoming crucial. Also, the rise of real-time data. ETL isn't just batch anymore, it needs to handle streaming data from Kinesis or Kafka, often via MSK on AWS.
So faster insights.
Yep. And the central role of the data lake, typically on S3, cataloged by Glue, maybe queried by Athena, ETL's job is increasingly about efficiently populating and maintaining these massive, flexible data lakes, not just structured data warehouses.
So ETL has to keep evolving as the ways we use data evolve. Feeding ML, handling streams, managing lakes.
It has to keep pace.
Okay, so after this deep dive across all these sources, what's the big takeaway for you? If someone asks, which AWS ETL tool should I use?
The clearest message is there's no single best answer, even just within AWS. The right tool, Glue, EMR, data pipeline, DMS, maybe even sticking with Informatica, it completely depends on your context.
Context
Like your team's skills, Python, Spark experts, or experts in a traditional tool. Where's your data? All in AWS or lots of external connections needed? How do you want to operate Love serverless or need fine-grained cluster control? What do your workloads look like? Small and frequent or massive and complex? And that total cost, including the people, time, and licenses, you got to weigh all that.
And where does Glue usually land in that evaluation?
Glue often comes out as a really strong default choice, especially if you're already leaning into AWS and cloud-native ways of working. It hits a great balance of simplicity, power, and cost for many common ETL jobs, particularly within the AWS ecosystem. It takes away a lot of the infrastructure pain.
This has been super helpful for navigating all these AWS options. As you look at your own data setup, the sources of data, the formats, the need for speed, it's just getting more complex, isn't it?
It really is. So maybe a final thought for you to chew on. How are you going to keep evaluating your data integration strategy to make sure you're not just moving data around, but actually getting the most value from it efficiently and affordably? When you face your next data challenge, think about what's really driving your decision. Is it the raw cost, the speed to get it running, the technical complexity? Or is it mainly about what your team already knows how to use well?
Good question. Definitely something to think about.